Hi students, welcome back. Today's topic is machines. In this video, we will study about what is machine, function and uses of machine, then what are the technical terms like load, effort, fulcrum, mechanical advantage, velocity ratio, and then efficiency calculation, and then the relationship between efficiency, mechanical advantage and velocity ratio. So let's start this introductory video about machines. What is a machine? Simple machines are basic mechanical devices for applying force and doing work. As you can see in this picture, an inclined plane is also a type of a machine. Physics says that it is a machine. When you think of a machine, you will think of a washing machine. You may think of a sewing machine. But this simple inclined plane is also a machine according to physics. This wedge or an axe is a machine. Levers, hammer is a machine. Pulley is a machine. Screw is a machine. Wheel and axle are machine in physics words. How come they are machines? Let's see. How does physics define machines? Physics define machines as devices for applying force and doing work. What is force? We all know that force is equal to mass into acceleration, and force is measured in Newton. And then what is work? Work is equal to force into displacement, right? When the displacement is zero, then work done is zero. But machines involved force and work. Let's see this inclined plane. In inclined plane, what happens? Here the inclined plane is put and over it we apply a force. A force is being applied to the box and the box is being moved or displaced a distance. So there is a force involved, then there is a work done because with force there is a displacement involved. So wherever force and work are involved, then it is a machine. Now what are the function and uses of machines? As you can see in this picture, you can see a car is being lifted up. So machine is one which helps to lift heavy loads. Let's say a machine is of 5 kg, but if it can lift a weight of 50 kg, then it's a machine. So one function of machine is to lift high loads. Then second one, as you can see here, machine is used to increase speed. Third one, as you can see, if we draw a bucket of water from the well using a pulley as shown here, we apply force in a downward direction, right? Here the force is being applied in downward direction, right? The force is being applied in this direction, which is much easier than pulling the bucket upward. So it helps to change the direction. Then here, as you can see in the picture, scissor helps in separating or cutting. Machine does that. Now, what is the machine in actual physics definition? A machine is a device by which we can overcome a large resistive force or load. So load is a resistive force. Force means it's measured in Newton at some point by applying a small force. Small force is effort. At a convenient point, a desired direction, we can obtain a gain in speed. From this definition, we see that force you produce is the load. Load is a force you produce. Force you apply is known as effort. Effort and load both are force. One is the force that is you apply, that is effort, and the force that results as an output or produced force is load. And what is fulcrum? The fixed point is known as the fulcrum. Now let's see this example. Again, effort is being applied here. Effort is in force. So effort can be measured in Newton. Suppose force applied here is 30 Newton, let's say. And the load applied here is 60 Newton. Load is also a force. Now the distance from this fulcrum to the effort effort point is known as effort arm. Similarly, the distance from the fulcrum to the load point is known as load arm. Now we know what is load, what is effort, what is load arm, what is effort arm. Now let's see what is mechanical advantage. Now mechanical advantage, I am writing here shortly as MA, is the ratio of load by effort, right? So I can write here load is measured in Newton, effort is measured in Newton. So what will be the unit of mechanical advantage? It has no unit because Newton and Newton get cancelled. So mechanical advantage doesn't have any unit. It's a ratio of load to effort. Now suppose if the mechanical advantage is greater than 1, how can it be possible? When will be the mechanical advantage greater than 1? When the load is greater than 1. You can write here, if load is greater than effort, then mechanical advantage is greater than 1. And where it is used as a force multiplier. When mechanical advantage is greater than 1 means load is greater than effort. As in this case, load is 60 Newton and effort was 30 Newton. So we apply a small force and we could overcome a large force. So what is the force multiplier? Force is 30 Newton into 2, 60 Newton. So it's used as a force multiplier when the mechanical advantage is greater than 1, that is load is greater than effort. When if suppose load is smaller effort, what will be the mechanical advantage? Mechanical advantage will be lesser than 1. So this is the case where we need machines to increase in speed. If load is equal to effort, then what will be the mechanical advantage? It will be equal to 1. When mechanical advantage is equal to 1, it can be used to change in directions, like in case of pulley. Similarly, another term that is associated with machine is known as velocity ratio. Let me write it as short form VR. What is that again? Velocity ratio is the ratio of velocity of effort by velocity of load. Now what is velocity again? Velocity is same as speed with the direction. So I can write speed formula is distance by time. Velocity's formula is displacement by time. Here the displacement of effort is dk, right? So I am writing here dk. It would be easy for me if I write de, right? Effort arm by time. Similarly, velocity of load is db. Here it is db. Let me write it as dl, load arm by t. So what will happen? tt cancel. Then what we get? It's velocity ratio is the ratio between effort arm by load arm, right? So this is another term, that is velocity ratio. It's a ratio between effort arm by load arm. If VR or velocity ratio is greater than 1, in which case it will happen? If effort arm is greater than load arm, then what will happen? When effort arm is greater than load arm, then it's used as force multiplier. Similarly, if VR is smaller than 1, which will be the case? If VR is smaller than 1 means load arm is greater than effort arm. So in this case, it will be gain in speed. When VR is equal to 1 means load arm is equal to effort arm. In that case, it will be used for change in direction. So the terms associated with machines are: one, load, which is a force, of effort, which is also a force, then mechanical advantage, it's a ratio of load to effort, and then velocity ratio, which is the ratio of effort arm by load arm. So these are the technical terms associated with the machines. Let's see this picture one by one. As you can see, the effort is being applied at that point. Next, coming to the seesaw. The load is being applied by this boy. Similarly, in this claw hammer, we have a load at the point where the nail is to be removed and the effort is applied as shown in the arrow, and there is a fulcrum or fixed end. Similarly, coming to this Caesar diagram, load is the place where we cut, effort is being applied by the force that you apply with your fingers, and fulcrum is the fixed end. Now, what is the principle of machine? Machine usually works under a principle that whenever energy is supplied to a machine by applying an effort or a force, it does some useful work on the load. So if you supply some input work, as it is written here, input work or input energy, then obviously you will get some output work. Input work will be by applying a force or an effort, we will get some work on the load. I have already told you what is the formula for work. Its work or energy is equal to force into displacement, right? Similarly, output work will be also, work output is also force into displacement. In case of output work, what is the output force? It's load in case of machines. And what is the displacement? It's the load arm. Load arm. Similarly, here I can write input work. The force is effort. Into the distance moved is effort arm. Now let's see what is an useful device. Let's see, this is a device which is marked in a green color. Any appliance, domestic appliance like washing machine or maybe an electric bulb, simple machines. You give an input of energy of 300 and you get some useful energy output. Let's say it's suppose 150 and there is a waste energy of 150. According to conservation of energy, that energy can neither be created nor be destroyed. It can be transferred from one form to another. So let's see, a machine has an input of 500 watt and it weighs 300 watt. Calculate the useful energy and the efficiency. Now total input energy will be how much? Useful energy plus wasted energy. As you have seen here, input energy is useful energy plus wasted energy. So what will be the useful energy? Total input minus wasted. We know that input is given 500 and waste energy is given 300. So minusing it, we get 200 watt as the useful energy. Now what will be the efficiency? Efficiency is the formula that you need to know. Efficiency is equal to output useful work, work output by input work into 100%. So here useful work. So here only we have written what is efficiency. It's useful energy, that is 200 by total input into 100. We get as 40%. Efficiency has a symbol, that is eta. And what will be its unit? It doesn't have a unit. Why? Because output energy, input energy get cancelled. So it's a percentage. Now actual machine and ideal machine. Let's say again the same thing. Input energy we have supplied some. Output energy, as you can see, is very less. Wasted energy is more. Here we can see the example. 100 joule of electrical energy was supplied. We get light energy of only 10 joule and waste energy is 90 joule. Let's calculate the efficiency here. Efficiency is useful output. Useful output is here 10 joule, right? Input is 100 joule into 100%. How much you will get? It is 10%. So this machine is only 10% efficient. Now actual machines are those where the output, useful output energy is always less than the input energy. But what is an ideal machine? Ideal machine states that input energy is always equal to output energy. So in case of ideal machine, input energy is equal to output energy. There is no loss or no wasted output energy. But in actual machine, it differs. There is some wastage of energy due to friction, or there may be any other heat energy. There may be some loss. It's perfectly okay for an actual machine to have a loss. So in an actual machine, there may be energy loss due to the following reasons. Maybe due to moving parts which are not weightless, which are neither weightless nor smooth. Then there may be due to string in it, it's not perfectly elastic. Maybe the parts in it are not perfectly rigid. So there is energy lost in overcoming the force of friction between the moving parts of a machine, which is a common type of loss. The main cause of loss of energy in an actual machine is mainly due to friction. So this is about actual machine and ideal machine. Now coming to the relationship between efficiency, mechanical advantage and velocity ratio. This relationship is important in the sense you may get some 2 marks problem on it. So first, work input is force into displacement. Force here is effort. Effort into displacement of effort that we have written. Again, what is work output? It's load into displacement of load. So we have written that. Then what is efficiency? It's work output by input. So what will be it? Let's write it here. Work output by work input. It's like work output is L into D load by work input is E into D effort, right? That we can write L by E is known as into what? D load by D effort. What is L by E? We all know that it is mechanical advantage. So L by E is mechanical advantage. And what is DE by DL? It's VR, right? We know D effort by D load is VR. So in place of L by E, we can write ME, and in place of DE by DL, we can write VR. So here what we get, efficiency is equal to MA by VR. Now what will be MA then? It's efficiency into VR. So this is the relationship between mechanical advantage, velocity ratio and efficiency. So thank you for watching this video. If you have any doubt, you can mention in the comment section below, and please subscribe to my channel for more videos.